All right, I wanted to take a look at atmospheres and other planets to show you some differences, and let's talk about that. Mercury, the closest planet to the Sun, has no atmosphere. The reasoning on that is, we don't really know. We can hypothesize about it. One of the hypotheses is that the solar wind that I talked about, the streaming away of charged particles, has stripped away its atmosphere. That's one hypothesis. Okay, our nearest neighbor toward the Sun, Venus. I think that the really important thing I want you to take from this is its atmosphere today. It does have an atmosphere, and it's 98% carbon dioxide. All right. A couple of other interesting things. Check out the average surface pressure. Remember what ours was? We call it 1,000 millibars. The average surface pressure on Mercury, or rather Venus, is 90,000 millibars. That means there's 90 times the pressure on the surface. The first successful soft landing on Venus was done by the Russians, spacecraft called a Venera. And Venera didn't last long on the surface. They got crushed by the atmospheric pressure. Of course, if the pressure didn't get it, the temperature was going to get it. 500 degrees Celsius would be about 800 degrees Fahrenheit average surface temperature. Okay, let's go to Mars. Now, we know a lot about Mars today because we've landed, I believe it's a total of 6 different surface rovers on it since the 1970s. We landed 2 in the 1970s you might not be aware of. So we have a lot of information about Mars. Thing I want you to take, look at that, it's atmosphere. It's almost all carbon dioxide. So Venus and Mars are almost all carbon dioxide. And this gives us a little hint, like I say, into what we think our atmosphere was like. Because remember what why do we have so little carbon dioxide? We have 0.04% today. Why is our atmosphere has so little CO2? What's the reason? Plants photosynthesize, taking the carbon dioxide out and returning oxygen. So when we see these very large amounts of carbon dioxide in the atmospheres of Venus and carbon dioxide, what would that tell you about photosynthetic life?
No life.
Probably isn't it? Okay, and that's what we've thought for years. You know, we thought, well, there can't be any plant life on Mars or Venus because look at this. You know, it's got way too much carbon dioxide. Now, another interesting thing, 7 millibars. That's like hardly any atmosphere. So the atmosphere is very thin on Mars. And again, some of the there's some speculation on why that might be. Again, solar wind, possibly stripping it away. The average surface temperature, now that might look cold to you Arizonans. It's just a chilly night for us Canadians. No, I'm just kidding. But the point is minus 60 degrees Celsius is about 70 below 0 Fahrenheit. We've seen temperatures colder than this on this planet. So, you know, we start talking about habitable planets, livable planets, this kind of thing. We've always had our eye on Mars because, yeah, it's a bit chilly there. But I mean, it's not like we haven't seen those kinds of temperatures here. And, you know, there is a move afoot to send humans to Mars.
What is that in Fahrenheit?
This would be about minus 70, maybe minus 75 Fahrenheit. But we've seen temperatures of minus 110 Fahrenheit in the South Pole. The record temperature in the lower 48 is right about there in Montana, 73 below 0. So, I mean, it's not like we haven't seen these temperatures.
What would be cool is if we could actually change that number.
You know, that's a really interesting point because there is some looking, it's called terraforming. And we think that, it's kind of a wild and crazy idea, we think there's a possible way to do this on Mars. If you're really interested in terraforming Mars, talk to Dr. Jeff Bevers, who teaches biology here. He's very into that, and we've discussed that issue before. It's very complicated, I don't really know how they do it. But we do think we can send humans to Mars. Now, there's some pros and cons of that one for sure. One is the expense. You know, it's expensive and dangerous to send humans into outer space. Yeah, it's basically a private program. And what they're looking at now, our government, NASA, wants to get out of the space business. We've seen that. You know, why might they want to get out of the space business? Like I say, it's expensive and it's dangerous. Even during the Apollo mission, we lost 3 astronauts, got burned up in an Apollo capsule just sitting on the pad. They weren't flying anywhere. They got burned up and incinerated in the capsule. And then we got into the space shuttle program. I think it was a little less than 150 missions. How many were fatal? 2 missions completely fatal. 1 on takeoff, 1 on landings. What did we lose? How many did we lose? Like 15, 20, 25 astronauts dead in the space. What's that? Yeah, that was the 86, the Teacher in Space program. Krista McCullough was killed. You know, so when you look at that, let's round it off to 150 missions with the space shuttle. 2 were completely fatal. Now, the next time you get on board an aircraft like Southwest out of Phoenix, and they say, well, you know, we lose 2 out of 150. Are you getting on that plane? Jupiter. Remember what I said about our earliest on atmosphere? Well, look at Jupiter. Helium and hydrogen, primary ingredients. Yeah, it's definitely cold. You're getting further from the sun, so its average temperature is minus 110 Celsius. Saturn, look at the atmosphere. Hydrogen, helium, like we think our old atmosphere was. Did you know this planet had rain around it? The thing here, now this is interesting, hydrogen and methane, okay? Methane and hydrogen are organic compounds, organic elements and compounds. Forms life, right? So we got kind of interested in some of these outer planets. Neptune as well. Nitrogen, organic compound. Methane, organic compound. Now just because they have organic compounds doesn't mean they have life. But let me point out Pluto. Is Pluto a planet? Where are we at with Pluto these days? We demoted it, didn't we? Yeah, dwarf planet. Dwarf. What is it? I'm going to go to this one. We'll come back to it. You know, we talk a lot about is there life on other planets, and yeah, what do we got 8 or 9 planets in our solar system? You know what? You know how many moons are in our solar system? Over 100. Saturn and Jupiter have over 40 moons each, and they're starting to look like very interesting places. Give you an example. Titan is a moon of Saturn. We've observed Titan through our telescopes, and it's got an orange atmosphere, orange clouds. We've never seen the surface of Titan. We suspect that orange cloud might be methane, but we didn't know. So back, oh gosh, it must be getting close to 10 years now. I think it's maybe 8, 9, or 10 years now. We sent the European Space Agency and the United States combined to send the Cassini-Huygens probe into outer space. What it did was Cassini initially went into orbit around Saturn, did fly-throughs right through the rings, so we know all kinds of stuff about the rings now. But it had another probe bolted onto it called Huygens, blasted off from Cassini. And the idea was to soft land it on this moon right here. This is an artist's conception here. This would be the probe. Well, you can view this video if you want. Probe goes down through the clouds, parachutes come out. Camera is running on the bottom of this thing as it descends through the clouds, and then boom, opens up out of the clouds. First time ever we saw the surface of Titan. You know what we saw? Liquid lakes all over the surface. Temperature is, going to be about minus 190 degrees Celsius. What's going on? Turns out that cloud was methane. That liquid is methane. It rains methane. Methane's a liquid at minus 190 degrees Celsius. Methane is an organic compound. We have some really interesting stuff in our own solar system right here. So we haven't found any life there, and this thing winked out pretty quick. It didn't last too long on the surface, but it took a lot of really good photographs. For example, it landed in what looked like an old riverbed, and all of the rock that looked like rocks in it were rounded. Remember what we said about rocks that are moved fluvially? They get rounded. So it looks like it can sometimes rain methane, liquid methane runs down these rivers and then forms these lakes. So some really interesting stuff in our own solar system. And that pressure is pretty similar to ours. Remember, ours is about 1,000 millibars. Let's go back to the moon. Now we, back in the glory days of U.S. space travel, we landed several humans on the moon. We know quite a bit about the moon today. And this is what happens when you don't have an atmosphere. You have no greenhouse gases to absorb long-wave radiation and re-radiate it back and forth all day long. No atmosphere. The sun heats the surface up, and the temperature just above the surface can reach 107 degrees Celsius. That's about 230 degrees Fahrenheit. Nighttime temperatures can drop to about 200 below 0 Fahrenheit.